Hello everyone. Today is the seventh day of our linked list journey, and for today we have solved three questions. And the first question is rotate linked list by k times. So, for example, we have a linked list of five nodes 1, 2, 3, 4, 5, and our k value is 2. So, for this, we have to rotate the linked list by 2. So suppose if we rotate it by 1, so our result will be as 5, 1, 2, 3, 4, and after by 2, our final return result will be as 4, 5, 1, 2, 3, and we have to return our linked list. So this is the description of question. So for the solution, firstly we will traverse our linked list and calculate its length, and after calculating the length, our target will be as to move to the pointer to move our pointer to the linked list node 3, and then we will add our tail to our head, and after adding our tail with our head, our node 3 will be point to null, and that's how we will solve this problem. So for the solution, firstly we create a temp, and our temp will move up to our tail and calculate overall length, and after this our tail will be connected to our head, that's temp.next will be connected to our head, and for calculating the length over after calculating overall length, we will get our expected node that will be as tail for future purpose. So for that we will calculate that point by using overall length minus k counter, and by this we will get up to 3, and we will make a function by which we will traverse up to that length, and eventually reaching at point 3, and 3 dot next will be turned as our null, and that's how we will return this, and our question will be solved. So this is the first question. For second question, our question is merge two sorted linked list. So in this we have two sorted linked list, and they are sorted individually, and in the end we have to sort and merge them and make it in a single linked list. So for this, a brute force that we can solve is by taking a new list and simply putting elements in that, and sort them by using a sort function, and after using that sort function we will able to sort that and return our head. So that's the brute force. For brute force, complexity will reach like we will traverse our first node up to end and traverse second node, so n1 plus n2, and for the sort function we will use n log n space, and for putting them in a new node, so that will also take big O of n. So overall complexity reaches maximum, and space complexity, as we are using a new array and a list, so we are taking big O of n extra space. So to optimize it, we will use the concept of two pointer approach, where we will have a t1 at our head 1 and t2 at our head 2, and we can take a new list and simply add our and compare both the list nodes, and whichever will be smaller will be put in the new list. So that's how we can solve this problem. But we are taking the extra space of a new list, so we can ignore it by using a dummy node concept. So as in our previous journey we have known the dummy node concept, so we can use dummy node and simply connect these node, uh, and we will able to solve the question. So firstly we will take a dummy node, our temp will point to dummy node, and then we will compare them, and whichever will be smaller dummy nodes next will be point to that node, and after this that temp will move forward, and then we will compare both nodes, and whichever will be smaller, our dummy nodes next will be added to that node, and that's next will be compared again, and this process continues until we reaches to the tail end. And after reaching to the end, our question gets sorted and solved without using any extra space, and without traversing again and again. So that's how this question will be solved. So our last question is flattering a linked list. So it's a hard problem. Firstly, there is a new concept. So what is flattering of linked list? So in this question, the question says that we have a linked list, and every linked list node have their own child, and their child may be null, or maybe they have their child, and their child may have their child, and they also may have next node. So this is the flattering means. Okay, we have a linked list, and every node have their next node, and every node have their child also. Maybe there will be no child, maybe there will be a single child, and that single child may have another child, and that may continue. Means a linked list, and that linked list have horizontal their self linked list, maybe child linked list we should say. So our task is to sort the overall linked list, the linked list that is given, and their child also. So we have to return a child linked list where we suppose so for theory, like I think I will provide the image if possible, so we can know about the linked list, how it look like. So for this question, we have a linked list, and their child linked list are in sorted form. So for the brute force approach, firstly we will take a linked list, and we will make another new linked list, or firstly we will put every element in a new array or any other data structure, and we will traverse through each and every node. Like firstly we will take a temp node, and we will move again and again up to the temp reaches to the null, and while temp moves forward direction, we will take another pointer as t2 that will move downward direction, and temp will moving from left till right, while t2 will move for every node. T2 will move from their top to their bottom until they got to reach to null. After reaching null, simply we will add on those elements in our array. After adding all the elements, we will sort the array, and after sorting that array, we will make another new linked list, and we will put every element that will be sorted array element in our linked list, but not in a not in a horizontal direction. We will put them in a vertical direction. Like previously we have solved for a vertical for a horizontal direction sorted linked list, but this is a new concept, and for this we will be traversing in our linked list in vertical direction, and simply taking a new head, and sorted elements will be put like first sorted element will be put in that head pointer, and then head next. In place of head next, we will use head's child, and put in that part as our new element, and creating a new place there also. So for this, our complexity will be much higher, and that's the brute force that I can think of as of now. I can think of this, and for the solution, for the optimal solution, I will think much more and will come with the solution tomorrow. Until that, I hope I will be able to solve linked list as soon as possible, as today is the last day of linked list journey. But unfortunately, it was not able to solve all the question because of some hard problem. I get stuck in that problems. So I will be covering them in next 2 days maximum, and then we will be starting stack and queue. Until then, stay tuned. Thanks.